Hello, and a warm welcome to our webinar. Today goes out to our customers, students, power electronic engineers, and last but not least, to our competition. My name is Emilio Meza, and I'm your moderator for today's webinar titled SKiiP for SiC, the first silicon carbide intelligent power module for 1500 volt applications. The SKiiP for SiC is an intelligent power module, including driver, current sensors, and heatsink, and enables anyone to take advantage of SiC without incurring the development costs, sourcing issues, and risks associated with deploying the latest power semiconductor technology. Before we get started with the presentation, some words about our webinar platform. In case of connection issues to the presentation stream or the sound, please try to reconnect by refreshing the browser window. In your browser, on the right-hand side, you see the chat window, which you can actually hide to increase the screen space for the presentation. In case you have any questions about the content or technical difficulties, please let us know via the chat. All messages are private and only we can see them. We will try to answer your questions at the end of the presentation. The questions we do not manage to answer today will then be answered by email during the next days. Also, you can send us an email to webinar@semikron-danfoss.com anytime, and we will get back to you as soon as we can. Lastly, we will share the presentation as a PDF at the end of the webinar. Your presenter today is Anastasia Schiller. Anastasia studied electrotechnical engineering and business economic management. From 2011, she was the product manager for SkiiP and SKIM 93. Last year, she became the head of product management for SkiiP and drivers. Enjoy the webinar. Anastasia, the floor is yours.
Hello, everybody. I'm quite excited and quite happy to greet you in our webinar study again today. So 4 months ago, we had a webinar regarding SKiiP 7 IPM. So thank you very much for your very positive feedback I have got after the webinar. It's really important step in the implementing of IGBT7 for the future of the power converters. Today, we will continue with the cutting edge of technology with our SKiiP IPM. And today, I will present you the newest member of our SKiiP IPM family, SKiiP for silicon carbide IPM. We will start with the same slide as it was for SKiiP 7. So just to get an understanding what the SKiiP is. As you can see on the picture, we have power modules that are mounted onto the heatsink. We have current sensor included in the power module, and we do not have any base plate. That means that the power modules are mounted directly onto the heatsink. The heatsink can be water, air, or customized heatsink, so depending on the application we are talking about. And last but not the least, the driver is also part of the assembly, including protection functions over current, over temperature, and over voltage protection. This all designed, qualified, and then assembled and end-of-life tested is then a SKiiP assembly, SKiiP IPM, Intelligent Power Module. And today we will talk about SKiiP 4 SiC version. The design of SKiiP 4 is dedicated for application with higher voltage. We have a lot of technology advantages inside, so that the 1500 volt application with silicon carbide MOSFETs can be implemented successfully. Here on the picture, you can see the explosion drawing of SKiiP for half bridge. You can see the bus bars sandwich, so it's called, separated with isolation foil. And on the picture, it can be seen that each chip has its own contact areas, so that the inductance in the module is optimized and the current sharing is homogeneous. Chip substrate is sintered. We will come to this topic later. That means that the reliability of the module is quite high, and we do not have base plate, as already mentioned. That means that the thermal performance of the module is optimized. We use high performance thermal interface material and high performance heatsink in the SKiiP. That means that special pin-fin structure is created depending on the position of the chips on the substrate, so that the cooling of the module is very efficient. And in the last 3 years, we had funded project Next Wind that was placed in the cooperation with different partners. You can see them on the slide. The target of this project was to create the next generation of the converter for higher operation voltage. So it was not only 2-level SKiiP, and there were some discussions about 3-level applications, about 3-level power modules. The target was to increase efficiency of the inverter, to check the loss analysis and control algorithm that can be used to improve the efficiency of the system. Different topics were discussed, but the main output of this project was that we have created SKiiP for SiC for 1500 volt DC link as a product that use 2 kV silicon carbide MOSFET chipset. So different suppliers are possible. It's suitable for continuous 1500 volt DC link operation. All the required creepage and clearance distances are available in this package. And we have fully digital SKiiP 4 driver that is suitable to control SiC chips, and also have the previous functions that we had with the SKiiP 4, like can open interface and other control possibilities that makes the implementation of the control algorithms for customers much more easier. And today in our presentation, we will discuss what are the advantages of intelligent power module for silicon carbide. We will check what is good for design and qualification, for production and yield, what need to be considered in the test specification and the test equipment. We'll discuss early failures, integrated driver, the independency of the chip that we have in our module, the possibility to make a tailored modules for the special projects. We'll discuss the short circuit behavior, and I will show which support tools and documentation you have with the SKiiP. So the silicon carbide technology is still quite a new technology for a lot of applications. Of course, the benefits are can be seen, but there are still some challenges in the implementation of this technology. The one of them is that silicon carbide technology has a lot of differences in comparison to the well-known IGBT technology, and some experience is needed to create and to design products that are based on the silicon MOSFETs. Also, qualification efforts are significant. The definition of tests that need to be done and qualification itself is a big challenge. A lot of efforts are needed to make it properly, not to overstress the modules, but to find the weak moments that must be eliminated. With an IPM, the customer will get ready designed and qualified product where we use the experience that we have with silicon carbide modules and with automotive modules that we have, so that these efforts do not need to be over-dimensioned. So we have a qualification lab where we have possibility for different tests. We have also certificates. We have a lot of silicon carbide testing knowledge, different equipment that we can use. Also qualifying some customer-specific tests. We also have access to the external labs that can make some special tests if it's needed. So this is something what we can develop together with our customers so that they can leverage the know-how that we have. There's not only a challenge for design or qualification, also for production and for yield consideration. The new technology is a big challenge. The end of line test, the production process, everything needs to be reconsidered with this new technology. With IPM, we have already implemented 100% part that we produce in our production have the functional electrical and burn-in test as a must already today. So we have since 20 years at least. So the control yield and low logistic efforts. In case some matching for the silicon carbide MOSFETs are needed, are expected for the customers. That means we will overtake this additional efforts if it's needed for some silicon carbide MOSFET types. With a new technology, the scrap rate is always a high risk. So it's not clear what is the normal, what is the special effects. So it's something where a lot of experience is needed. Also, risk for early failures is significant if the test is not appropriate. As already said, in our production, we have since years 100% functional electrical and burn-in test implemented. So we have controlled yield and low risk for early failures. The early failures is anyhow a big problem for a lot of the modules. So it's failures that we do not want to have in the field. So if the product is delivered, it's not it's not good when we have some early failures in this area. With our 100% burn-in test, where we test the modules almost at the maximal possible junction temperature, allows us to find the defects in the chips and in the module itself at the earliest stage, so that this scrap will stay by in our production and will not be delivered to our customers. Considering the costs of silicon carbide chips, it's a quite high amount of money that can be saved. And the yield is under control. Talking about technology benefits of SKiiP 4, we can start with a chip attachment. So we have sinter technology implemented in SKiiP 4 since 15 years already. So it's something that we do, and it's a well-known process. And this has a very high impact to the lifetime of silicon carbide MOSFETs as well. With the chip top contact, we still are going to use bond wires, but not standard aluminum bond wires, aluminum copper bond wires. So that's aluminum cladded copper bond wires that improve the lifetime of the modules. We have already seen the terminals connections. That means that each chip has its own bus bar leg, so that the current sharing in the module is optimized. So that's an additional reliability for passive and active temperature cycles. We also have no base plate, as it can be seen on the picture. So with high performance heatsink and with high performance thermal grease, we have good thermal performance so that small silicon carbide chips can be cooled properly. We will discuss all these topics in details now. So in the picture, you can see the sinter technology. It means that we have silver powder that is pressed in the high pressure and high temperature in the special oven, so that we have very good joint connection between die, chip, and DBC. Aluminium copper bond wires come on top of this chip. You can see the connection on the picture. So that means that aluminium area of the bond wire can be connected to the top chip metallization on the surface of the chip, but the current capability and the reliability for the lifetime is much higher than with the standard bond wires. Another topic in the design is the base plate. So the technology for SKiiP is the press technology. That means that the bus bars are pressed with this pressure part on top of the module, so that the whole contact inside of the module is without any welding or soldering. It's all about the pressure. And on top of the module comes the springs that make the contact to the driver. That means that we have very high possibility for the shock and vibration stress. So it's not so critical for the SKiiP module. You can see it on the picture. So we have the example of the heatsink, and a very thin thermal grease layer comes. It's for SKiiP something like 22 micrometers. So you can imagine it's a very, very thin layer. Then comes the ceramic substrate, this direct copper bonded ceramic substrate, and then the chip comes directly, so that the RTH of the whole construction is actually minimal, so that the cooling for this small silicon carbide chips is optimal. And we also do not have these additional layers that can fail during the power cycling, because we have eliminated them out of the construction of the module. On the picture, we have standard module, so it's not a silicon carbide layout, because this picture, it's only to explain how we make the construction of the bus bars. Each chip on the DBC has its particular bus bar leg, so that the current sharing in the module is homogeneous and the current paths are quite the same, so that the strain distance is reduced and we have a homogeneous current sharing in the whole system. In addition to this, this is mechanically decoupled system. That means that if we apply pressure to some part of it, it will not destroy the DBC, so the ceramic substrate. Now we are coming to our high-performance heatsink. In the areas where we have the chips, we have pin fins. The structure of the pin fins is optimized to get the best possible thermal performance, so that because the silicon carbide chips are quite small, the concentration of heat is quite high. So it's very important to have appropriate cooling to get much more power out of the module. We also have designed the high performance grease pattern for the modules, so that the thickness of this layer is minimized and the thermal performance of the overall system is optimized. For these advantages, we have either higher performance or we have increased lifetime, considering the whole system. SKiiP 4 silicon carbide IPM has also integrated driver with reinforced isolation. We have a possibility for gate voltage adjustment in the driver itself so that we can control silicon carbide chips from different suppliers. We have a possibility to change the gate charge so that we can vary the number of the chips in the module. We have our own SiC chips that be produced by ourselves. So it allows us to make some changes or some adjustments in the driver in the flexible way so that the whole system is optimized for special tasks. I have already talked that the interface is electrically isolated, and we have CAN bus connection with the possibility to parameterize the system depending on the application. So some protection function can be added or can be changed. So we have special application node where this can be read. The fiber optic interface can be used optionally. Due to possibility of changing of the gate voltage in the driver, we can use different MOSFETs supplier in our system. That means that we are not binded to one or two suppliers, so we can check the availability on the market or probably the preferences of the customers so that the flexible silicon carbide MOSFETs can be used for their final application. So the disadvantage of SKiiP that we have before, like a single source application, is now not so critical anymore, because with silicon carbide, the switching behavior of different chips is quite different. That means for a lot of modules, there is no second source on the market. With the SKiiP, we, however, have a possibility with adjusting of the driver switching performance with the testing or production process. We can change the design or qualification flexible on our side so that the customer can profit from using the multiple silicon carbide suppliers, because customer gets assembled and 100% tested intelligent power module and not only the power module itself. Another topic is that the price of the silicon carbide chips is still quite high. We have a possibility to offer to the customers the chips, the modules with varied number of the chips inside, so that we can tailor the rated current ratio to the application itself, depending on the required performance. So the price performance ratio can be optimized. The short circuit behavior is also a big topic at the moment. So depending on the chips, we have a different possibility. So we have integrated short circuit protection. At the moment, the offered protection is that the explosion can be prevented and the system will be stopped at the moment. But in general, we are making different tests and investigating the possibilities for repetitive short circuit event, so that the short circuit protection of the overall system is optimized. This is something that we can work on together with our customers for special application to understand what are the requirements and what we can achieve together. We have following SKiiPs available at the moment as samples. As already said, at the moment it's water and air-cooled versions, but we are open for discussion about customized versions. So if you have some other heatsinks in mind, this is not a problem for the SKiiP. In general, we have special requirements to the heatsinks, but no restrictions that some of the heatsinks cannot be used. all new SKiiP 4 types that are listed in the table are available in our SemiCell simulation module. So can be checked the performance. We have target datasheets available on request, and for a short time we have issued an application note for the silicon carbide power modules, where the explanations are given how the datasheets can be understood and much more information. So this is the tests that are planned for qualification of our IPM system. So you can see this 1000 hours H3 tier B is important, and also with the power cycling, the test result that we have for sintered modules with aluminum copper bond wires are quite promising. SKiiP IPM is not the Plunon Ultra solution. So in general, we also can order the SemiStack RE, that is a stack where you can order the SKiiPs together with DC link and AC connection already in one stack. This is available for 3 megawatt and 2 megawatt solutions for different voltages levels. Is water cooled, and the power rating is made for 6 kilohertz, but in general also other frequencies can be discussed. So if you would like to not to go through the whole learning curve for silicon carbide and just start at the end and to see which benefits you can have for your application with the silicon carbide, you can start with the stack. So as a summary for today, so SKiiP 4 is the most reliable IPM solution for demanding application, not only for silicon carbide, but also for IGBT technology. We have outstanding robustness against environmental and mechanical stress. If it's combined with advantage of silicon carbide technology, it can be quite interesting for a lot of different applications. We have integrated gate driver with our own ASIC that offers configuration and parameterization for different silicon carbide chip suppliers. It means that the customer can choose what will be used. With our new high-performance heatsink, the performance can be boosted further, or it's possible for reduction of system cost because the same performance can be done with less chips. Simulation tool is available, and as you can see on the picture, so SKiiP silicon carbide IPM or the stack can support our customers to leverage the advantages of silicon carbide technology earlier and to reduce the time to market. Thank you very much for your attention. If you have some questions, please place them.
Thank you very much for the great presentation, Anastasia. To the audience, I have just shared the presentation as a PDF, which you can find in the handouts area. We did receive quite a few questions that we will go through here in a moment. All right. A few people asked about this. What is the maximum switching speed of the SKiiPs? So with the driver and everything.
So the driver is not the limiting factor. So in general, we also have a possibility to 20 kilohertz to up to 30 kilohertz, but in general, the application needs to be checked. So if you have some concrete application case, let us know. We can make some simulation. We can make the calculation what will be possible to understand the safe operating area and the possibilities for the SKiiP, but driver is not a limiting factor.
Not the limit, more on the application. All right. Another question about the SKiiP. Will this be UL listed?
Of course, yes.
Of course. All right. Here's one looking at the humidity. So just to confirm, the SKiiP 4 is not a hermetically sealed module, but is there any mitigation for moisture ingress over time?
In general, the housing of the SKiiP is not 100% robust against of moisture. But the technology that we have inside prevents corrosion, prevents the failure because of this of humidity problem. But anyhow, we still have that climate class, I guess 3K. So it's not condensation is not allowed for the application.
Right, not hermetically sealed, but it's still resistant against humidity.
Yes.
I know there's quite a bit of tests going on about that, so it's very important here.
Yep.
Here's one that should be easy for you to answer. There were some products showing 4 terminals, others showing 6 terminals. Are there planned to have multiple variants of the SKiiP?
It also depends on the request. So this 4-fold that we have on the picture is our standard version where we can offer the samples today. In general, we are not restricted. So if the business case is good enough, we can make any variant.
Perfect. And then looking at the driver, so with the isolation, what is the isolation level between the control interface and the power?
We have some special slide we have some special information regarding isolation coordination. Probably it will be better that I will share this after the presentation.
I think so. Yeah. So we have that documentation, and we can certainly share it. And then there was a few people asking about. So there's multiple chips per switch, and there were a few people asking about any oscillations that occur, with having multiple chips per switch. Is there anything like that you're dealing with?
Yes, the oscillation risk is quite high. And that's why we make a lot of simulation, a lot of know-how, how we make the layout. We have a lot of technology advantages and SKiiP, as already said. And yes, so we have some oscillation, but we are quite sure that we can deal with this.
Yeah, I think that's the core competency of Semikron Danfoss, is handling multiple chips in a power module.
Exactly.
So then there's a question about short circuit. So what is the short circuit reaction time? And is there desaturation protection, or what's the blanking time?
This is quite sensible topics. We do not want to share all the know-how that we have. And of course, it also depends on the chip type that you have in the module. But yes, we have a lot of different possibilities with the desaturation protection and with fast reaction. And this is all that we take care about in the driver, correct?
Okay. And then there was a question about other voltages of silicon carbide MOSFETs integrated into the SKiiP. So here we're talking about 2000 volt silicon carbide. Are there any lower voltages planned at this time?
At the moment, not. But as already said, the design can be adjusted easily also to other voltages, especially for lower voltages. So as already said, if business case is okay, then we can discuss this.
Okay. And then let's see, are there, let's see, that's already answered here. There's questions about the stack that you're showing now, actually, the SemiStack RE. So generally, how are these tested? Is this done at full power, or how do we test these SemiStack RE types? Do you know that?
Do you mean end of line test or type test? Or?
I would say end of line test is my guess on this question for SemiStack RE.
So we have special testing cabinet where we can test them as a inverter. And as already said, it's not that we can test them with the standard test that we also use for the IGBTs. So there is a special test algorithms for test specification for the testing. Probably there are some detailed questions. What is?
Yeah, I think this is
very general.
A very vague question on that one, but okay. And of course, there's different things for qualification versus end of line testing to differentiate there. So I think you can answer this one though. What types of applications is this product geared towards?
So in general, we are thinking about energy storage and solar markets, but also hydrogen, or if there will be some some other applications. We have already requests for mining equipment, for off-road, so a lot of requests.
Okay. Varied applications. 1500 volt is certainly a big topic these days, especially renewables and those types. Let's see. Here's a question I'm sure you'll enjoy. What are the samples available, or if not, when can I get some samples?
So the samples can be ordered. We have a lot of requests. So starting, we want to launch this product on PCIM, and actually in June we will have the first samples for the customers.
Okay, so starting in June.
It can be ordered.
Okay, ordered now, but we'll have samples coming June.
Yes.
Okay. Let's see. We have quite a few questions. I'm just trying to get through all of these and figure out which ones we've already answered. What simulation models do you provide? Is it compatible with Plex, PSIM, LT-Spice?
No, at the moment what we have is our Semikron Danfoss simulation module SemiCell. We can think about creating of some simulation models that are compatible with other platforms, but they are not available at the moment. So then we need to discuss this.
Okay. And where do you plan to manufacture this SKiiP?
We have production sites in Germany and in China at the moment. We are discussing about US also, so we are quite flexible.
Okay. Let's see. Will this video be available later to refer to? Yes, I can say that's the case. I'm just trying to. We have lots of questions here. Is there a unique selling point? Unique selling points compared to other manufacturers. I'm sure you've talked about this quite a bit, but certainly can a little bit more.
The IPM is intelligent power modules. It's not only power modules, but with integrated driver. That means that a lot of challenges that we have integrated in the silicon carbide technology in the existing power converters can be skipped with our SKiiP. So this is what is the main topic for today. So it's the driver for the silicon carbide, the production, qualification, end-of-line test is already implemented. So it's not needed to be done by the customers.
Okay. And then let's see. Does the stack that you're showing here, or even the SKiiP that you're showing here, does it work as a bidirectional inverter?
Not like one module, but if we will make the special configuration, in general, we have no restrictions. So we have 4-quadrat inverter as well. And we also have Semistec RE solutions where we have bidirectional solutions for the customers.
Okay. Here's a question asking who the contact is for application discussion. And I will say we'll reach out to you for these types of questions after the webinar and discuss further application topics. So we can do that here. Let's see. Here's someone asking about finding data sheets or the new modules in SemiCell on the website. So is this already available? Data sheets and SemiCell models.
So I think they are not available in our internet. They are only available on request. So you need to contact your local sales partner for this.
Okay. So not available unless you request it. Let's see. And then I'll just ask one or two more questions here, and then we'll bring this to an end and follow up with the rest via email. So is the heatsink made of dielectric or a conductive material?
The heatsink is made of aluminum normally, but we have, as already said, directed bonded copper so that there is isolation between the chip and the heatsink. As already said, the heatsink can also be customized. So we have some heatsinks that are provided with dielectric materials so that the SKiiP is completely isolated. So we are open for any customized heatsink.
Customized heatsink, okay. And then I'll say the last question I have here before we just email the rest of the answers out. So what is the end of line testing for these SKiiPs, for all of SKiiPs? What is the end of line testing plan to be?
We have electrical test. That means that the electrical parameters of the chips are tested. We have a functional test because we have a lot of integrated protection function in the SKiiP. So overcurrent, overvoltage, over temperature protection for chips and for the drivers, and a lot of other functions are tested. We have the short driver test, and we make this burn-in test that is like a temperature cycling in our production. So the SKiiPs are tested almost 1 hour in the original junction temperature for the operation, close to the maximal operation temperature, so that the early failure and some defects in the chips can be sorted out in our production and do not come to our customers.
Okay. Well, Anastasia, thank you very much again. To the audience, thank you for joining the webinar today. I hope you could find it enjoyable and you could take away some useful information. I know that there was quite a few questions here that we have not answered that we had time to answer. So we will be following up on those topics. And if you have further questions, please contact us at webinar@semikron-danfoss.com. Thank you and have a great day. Bye-bye.